In this video, we are going to talk about how you can determine, first of all, if a triangle exists when given three measurements, and then if the triangle exists, how to decide whether it is acute, right, or obtuse based on knowing the three side lengths. So when you decide if a triangle exists or not, in order for it to exist, the sum, which means addition, so adding, so the sum of any two sides needs to be greater than the third. So if we just, draw a random triangle here and called this side A, this side B, and this side C. A plus B has to be bigger than C. Okay, so these two together, so when you add those, that has to be higher than C. When you add A and C together, it needs to be bigger than B. And when you add B and C together, they need to be bigger than A. So that is if you are just given expressions or whatever. If there's actually just numbers on the sides, okay, so if you just see numerical values, like if you see 5, you see 7, and you see 6, okay, then you only need to check that the two smaller numbers, so find the two smaller numbers, so the 5 and the 6, you just need to decide that those two smaller numbers are bigger than this one or not, okay? So 5 plus 6 in this case is 11. 11 is bigger than 7. So a triangle would exist in that case. Okay, so if you have numbers here, find the two smallest, add the smaller together, need to be bigger than the third. So let's take a look here. Whoops. Okay, so if we take a look at this, so does a triangle exist in this case? So 4, 5, and 10. So you can see there's a diagram here to kind of help you see this. So the longer side I've placed on the bottom, okay, so we see this 10 is the longest side. So then what happens here is then when you put the two smaller sides, the two smaller measurements on the end there, and then you think of them as a hinge, okay, because this segment, if it hinged around, it would be like a circle with that same radius. So this segment only has the ability to go this far. Okay, so hit all along this line here. And then the other one, the 5, also would be the same idea, thinking of this as a hinge, and it can rotate only 5 units. Okay, so then it's just going to hinge here. As you can see, these two blue segments would never cross, so they would never create a triangle. A triangle would never happen there. Okay, and so that's the visual representation. Okay, the other, then the mathematical way to represent that using the formula we just learned is to look at the two smaller numbers. Okay, add those together. So 4 plus 5 is 9. Okay, that is not bigger than 10. Okay, so greater than symbol, 9 is not bigger than 10. So then you have no triangle. Then for 1, 2, and 3, so again, in here, if we look at the formula, 1 and 2 are the smallest. Okay, so 1 plus 2 is 3. Okay, is 3 bigger than 3? The answer is no. Okay, so a triangle does not exist. And then again here on this diagram, okay, you can see that when we move this segment, okay, when we hinge this 1, okay, it can go to here, okay, so it goes all along here, and then this other segment, okay, the one that's 2 units long can hinge here. They won't touch until they're laying flat on top of each other, so there's no space in here, so it doesn't make a triangle. So when the two equal each other, they just lay flat on top of each other, no triangle is created. And then this final visual here, 4 and 5 are the smallest. 4 plus 5 is 9. 9 is bigger than 6, so a triangle will be created here, okay, as you can see, because these segments okay, are able to hinge this whole way and touch each other. Okay, so they were able to connect because they are wider than this bottom side. So by the time they touch, there's space in between here and a triangle has been created. So if we take a look at these examples, so first let's determine if the triangle exists, and then I will talk to you about how to determine if it is a right triangle. So first things first, you want to find the two smaller sides, in this case the 2 and the 6. So 2 plus 6 is 8. That is bigger than 7. So yes, a triangle exists. Okay, so yes, there's a triangle. Then you take and put this into Pythagorean theorem. And so c squared equals a squared plus b squared. And if it satisfies this, then you have a right triangle. So remember, c is always the biggest side. So c is the 7. So we'll do 7 squared. And then I'm just going to put a little question mark above this equal sign because we don't really know if it's equal. And I'm just going to put a circle, an opening here that I'm going to fill in a little bit. So 7 squared equals 6 squared plus 2 squared. So 7 squared is 49, okay, compared with 36, which is 6 squared, and 2 squared is 4. 49 in comparison to 40. Okay, so if this were a right triangle, these two numbers would be equal. Okay, so this is not a right triangle because these are not equal. So now you can actually decide if it's acute or obtuse based on if c squared is bigger or smaller than this 40. So if c squared is bigger, okay, then it's obtuse. If c squared is smaller, then it's acute. So in this one, the c squared value is bigger than the a squared b squared. So bigger means that this is actually an obtuse triangle. Taking a look at this second example, so again, look at the smaller sides. So 2 and 3 are the smaller. Add those together is 5. 5 is not bigger than 7. So there is no triangle here. And then you would stop because you can't classify a triangle when a triangle doesn't exist. Third example, look for the two smaller sides. So in this case, the 18 and the 21. So add those together. And 18 plus 21 is 39. 39 is bigger than 24. So yes, we have a triangle. Then we're going to decide what type of triangle it is by plugging it into Pythagorean theorem and seeing if c squared is bigger than, equal to, or less than a squared plus b squared. Remember, c is the biggest side, so we'll put in 24 here. So 24 squared, how does that compare to 18 squared plus 21 squared? So 24 times 24 is 576. 18 times 18 is 324. And 21 squared is 441. So then we have 576, and we'll see how that compares to 324 plus 441, which is 765. So in this case, the c squared value is less than or smaller than the a squared plus b squared. So this is an acute triangle. Given a triangle has side lengths of 10 and 18, so we have a triangle. So let me just draw a triangle in here of 10 and 18. What are the possible lengths in order for a triangle to exist of that third side? So we can't actually find the exact value, but we know it can't be too big or too small. Otherwise, we'll have something like this where the sides don't close. So this third side, I'm just going to call it x, and this is where we need to go back to remembering the three things that needed to happen. Okay, any two sides needs to be bigger than the third side. So I'm just going to start, okay, by taking two sides. So I know that 10 plus x, those two sides have to be bigger than the third side of 18. Okay, so 10 plus x has to be bigger than 18. Okay, and then x plus 18 has to be bigger than 10. And then 10 plus 18 also has to be bigger than x. So then you can just solve each of these, okay? So we'll subtract 10 from both sides, so we get x has to be greater than 8. That's one thing that has to happen. Here, when we subtract 18 from both sides, this is going to say x has to be bigger than negative 8. Well, it's a side length, so obviously it needs to be bigger than negative 8. So this is kind of an irrelevant statement, so we'll just cross that off. And then here we have 28 needs to be bigger than x. Or if I read this backwards from the x side, this says x has to be less than 28. So I'm going to write it like this. X has to be less than 28. So that's actually the range there, okay? So the smallest that x could be is 8. So x has to be bigger than 8, and it has to be smaller than 28. So the lower limit is 8, the upper limit is 28, and you can write an inequality this way. To say 8 has to be less than x has to be less than 28. And I like to read it from the middle. So if you read it from the middle, this says x is bigger than 8. So x is bigger than 8, x is smaller than 28. And a shortcut to this is that you just add these two numbers together and subtract them. So when you do 10 plus 18, you get 28. And when you do 18 minus 10, you get 8. So you get the upper limit and the lower limit just by adding and subtracting those.